All right, here we go. Happy Tuesday. Okay, we're doing our 1.9 notes today. Okay, we're going to start off by looking at our Explorer like we do every single day. Okay, so it says use the summary of the graphs from someone's personal fitness tracker to answer the questions following. Round percent's the nearest whole percent. All right, so we don't have to round to nearest whole. We can just go decimals, whatever. So first off, I want to talk about this, what this actually means. Okay, we're looking at a person's activity, a breakdown by hours and how active they are. This word here means just like time spent sitting or inactive. Okay, if you total up the number of hours, so our total is about, what did I get? 15 hours and 18 minutes. Which in terms of minutes, I got 918. That's our total from all of this data here. All right, that's all of this, okay? So from our data, this person was tracked 15 hours a day. All right, so we have to factor in sleep. So how long are they sleeping for? We'll talk about that in one of the actual questions, okay? So I'll circle back to that later. So the first question asked, that's 918, good. The first question asked here, during what percent of this person's waking hours is he very active? All right, so if I want to look back here, okay, how much time has he spent awake? That's that 918. Very active is 22 minutes. So 22 out of our 918 total minutes. So that's going to be 22 divided by 918. I believe you get like a 2 something. Yeah, which is 0.02396. And if I multiply that by 100, I get 2.397%. That's why I said don't round. All right, so I get 2.397%. That person is very active. Okay, what percent of the day does he sleep? Well, this is where that told you we'd talk about it later. So 918 minutes are spent being tracked. Okay, so we think about a normal day. If I do 24 hours times 60 minutes, there are 1440 minutes in a day. Minus our 918, I get 522 minutes. Okay, so of those 522 minutes, all right, well, how many minutes are there in a day? There are 1440. Remember, that's 1440 because it's 24 times 60. So I do the time that he spent sleeping, which was 522, divided by the total minutes in a day, and I get 0.3625, which is 36.25% of the day sleep. During which periods of the day does most of his light activity occur? Okay, so light activity is this green. So I would say, around here would be a time. Okay, so I'll highlight that. All right, so in here we're looking at, so that's about 8 and 9, between 8 and 9, and then where else? Down here as well, so between 4 and 6. How can I tell? Well, if you look like here, it's a little bit, there's a quick little spike. All right, there's a quick little spike. Here is a big clump of light. I mean, you could also include this 6, but since there's fairly active in there, there's some of this color. I guess you call that yellow. There's some yellow in there, and there's predominantly all green here, and there's predominantly green here. You could also say right here would work too, so I'll say around 10 because there's predominantly green. So we're looking from like 8 to 9. 8 to 9. Oh, buckets. 4 to 6 p.m. and around 10 p.m. I believe we also said 6 a.m. as well. Yeah, technically this would work a little bit, could consider it a little bit. 3 spots, I think we're good. What information does each graph give you that the other does not? So there's a lot going on here. I'm going to type this out since my handwriting is pretty tough sometimes, and just so you can read it easily. In our bar graph, it only tells us the activity levels. So only activity levels, not number of minutes. In our pie graph, gives us the total minutes, but not the time they occurred. So in the bar graph, I can tell what time things are happening. In the other graph, I cannot time things are actually happening. All right. So what are we going to talk about today? This is our overview of today. Can you read and understand information presented in a pie, bar, or line graph? When should a bar graph be used instead of a pie graph? And then can we make those, always make those in a pie graph? Okay, so here's our first example. All right, so it talks about, what are we talking about here? Hold on a second. So there's this little blurb that I forgot to put in. It's important. There are two different types of data that we're going to be talking about. We're talking about quantitative, which is measurable by a number, or it can be counted, and qualitative, which is, quantitative, quantity, like how much of something. Qualitative, I think a quality, like that describes someone maybe, all right, maybe like a color of a car or a name of a car, things like that, okay? In this example, qualitative would be the different types of activity. Quantitative would be the number of calories burned during that time. Okay. When you're just trying to display qualitative and make a comparison between a part and a whole, a great way to do this is use a pie graph. All right. So create a pie graph to display the following data in groups of college students who use 4 popular cell phone carriers. All right. So this is a qualitative data because we're talking about different names of cell phone carriers. So if you look here, the number of subscribers is listed for us. All right, so this is kind of how we would make a pie graph, okay, or the process that goes through. Excuse me, holy buckets. There's a big paragraph before this that I chose to cut out. Let's see if I can maybe bring that up. Yeah, right here. So before we can make a pie graph, we need to determine all this stuff, okay? There it is. I don't want to talk too much about that, but what we need to determine is the percentage that each little category is going to, has, okay? The percentage of that category, and then the central angle. So this is a little bit more confusing, the central angle portion. This is used to, help us draw our actual graph itself. This goes back to geometry days. The most important part is figuring out the percentages. All right. So understanding how to get these percentages, which is why we did this before, or why we have done this before. Okay. How they get these central angles is based on just a regular circle. Okay. So if you think about this, it says divide the number of subscribers in each category until decimals, blah, 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 multiply it by 100. Next, we determine the size of each little sector by finding the measure of its central angle. So we take the percent as a decimal and multiply it by 360. All right, so to get this 85-degree angle or something like that, I would just do 0.24 times 360. And why 360? Because there are 360 degrees in a circle. Why 0.24? Because 24% as a decimal is 0.24. And that's where that 85 comes from. Okay, they just use these numbers to help you draw a more precise graph. All right, do your best. I know that you're not going to have a protractor at home, all right, or a compass even, so that's okay. I'm not really concerned about that part of it. All right. This is kind of how one is created. All right, so let's try this. So it says, this is Ian attends a company-sponsored workshop designed to increase efficiency. His task was to create a pie graph of 8 hours and help him analyze how to better use his time, represent this information in a pie graph. Okay, so here's a work hours distributed as follows. All right, so you know that there is a total. Our total here is 8. Okay, so I want to figure out, the first thing I have to figure out is what percent of my pie graph each little category needs to be. All right, so I'm going to go down and I'm going to do every single every single number of hours divided by our total. So what I mean is the first one I'll do 1.5 divided by 8, and then I'll multiply that by 100 to see what I get. So I did 1.5 divided by 8 times 100. I get 18.75%. So I'm going to round that up to, and I'm going to put my percentages on the right here, 19%. Okay, it's hard to draw 18.75. So I want you to repeat that process, all right, and just go straight down. Remember, to get this 18.75, I actually had to multiply it by 100 after doing that division. Okay, but go ahead, figure that out, go for it. All right, here are my percentages, and you want them to add up to 100. Now mine ended up to 101. It's not a big deal just because of some rounding, but ideally, that your sum would be 100% because that would make the most sense. All right, so now we have to create our pie graph based on this information, based on these percentages. All right, so what's that going to look like? I find the easiest, I'll make this my percent category. Remember, when it's 0.5 or above, we round up. If it's 0.5 or below, we round down. That's how I got some of these numbers. All right, so let's talk about drawing this and making our pie graph. So the first thing I want to do, since I'm rough doing a freehand, I'm going to split it right down the middle. I find that that's easiest. Okay. Then I want to think about, all right, my first percentage is about 20%. So granted, all of these are not going to be, exact, but I'm going to say that's about this much. Okay. And that's 19%. And those are my meetings. So I'm going to write meet. I can say this is my 31%, and that's my comp time. What else? I got a little bit of off tasks, my calls. How did I draw this? Do your best. You want to make sure, obviously, the calls are less than a 19%. So that is my 13%. And those are calls. My breaks are a little sliver. That's a 6%. And that is breaks. Breaks, I could use one right now. I got breaks, I need lunch and off task. So I'd say this would be, let's make that a little bit bigger. Or this, which one is bigger? I'd say this one is probably bigger. Off. All right, so that's kind of a rough sketch. I mean, obviously, it's not exact. I mean, I'm freehanding it, so I don't have the central angles. That's kind of got a battle there. All right, let's see. What's our next one? Okay, there's this little thing that we talk about. Let's look at that. So now we draw the sectors. Okay, yada, yada, yada. Okay, we did that. Oh, right here. Another way to display data is a bar graph. All right, the bars are horizontal or vertical, touching or spaced apart, either or. When bars are ordered from tallest to shortest, that is known as a Pareto. I don't even know how to say that word. Pareto chart. Okay, that's when they're organized from tallest to shortest. Bar graphs are useful for looking at part-to-part comparisons, where pie graphs were part to whole. Remember that those were part to whole. Here we said that, part to whole. Okay, so now in bar graphs, I'm looking part to part. We create a Pareto chart to display the top 10 average prices by state in the United States. So this is an example of what? This is quantitative data. The data that we are looking at is the average gas price, all right, per state. Okay, I'm comparing the quantities. Here I'm comparing the different types of meetings. Here I'm comparing the quantities. Technically, I guess you could make a bar graph for this, but I'm comparing the part to the whole. Okay, I'm comparing part of my day to the entire day. Here I'm just comparing different parts of a gas price. All right. So luckily this was made for us. Okay, nice little average gas price by state. This would be an example of our Pareto chart, and because it's in descending order here. All right, that's how that would look. Okay, that's the biggest advantage of those types of graphs. A Pareto graph is that it's in descending order. Not all bar graphs are going to be like that. That is the specific type. Okay. Here we go. I skipped a little bit and we're coming here. All right, so this kind of just tells you how to make a bar graph. Okay, you can read that later on. I'm pretty sure you guys know how to do that. You've probably done that in a class. All right. So another way to compare quantitative data is to use a line graph, all right, which you have done before. Okay. So let's look at a line graph here. This data, this is talking about over-the-counter versus prescription drugs. Is often full of important, often mathematical information. The following graph, the vertical axis represents a concentration of at something in the body measured in micrograms per milliliter. Right, the horizontal represents the number of hours that have passed since the medication was ingested. The graph is constructed this way because the amount of yep, that big word, in the bloodstream depends on how much time passed since the medication was ingested. Since all values are positive, only the first quadrant is shown. The graph shows two different types of medicine. Use a line graph to answer the following question. So we have the adult liquid versus the extra strength tablets. All right, the adult liquid is the blue. All right, the extra strength tablets is the dotted yellow. Okay. The first question asks, write the ordered pair for the point indicated with the arrow and interpret it. Do not use abbreviations for units. All right. So the point looks like it is at 2,12. All right. So that would mean after 2 hours. I'm actually gonna type this out again so it's easier. All right, for you to read. So after 2 hours, the extra strength tablets, I'll just say its concentration in the bloodstream. Its concentration in the bloodstream is 12. What is the micrograms per milliliter? That's what this says. UG per milliliter. We're going to answer some more questions here. Same graph. Use the shape of the graph to describe what happens to the concentration of the medication in the body over 8 hours and why a dose is needed after 4 to 6 hours. Okay. There are a lot of different observations we can make. So let's look here. What can we say? I'm going to type this out again for you. Okay, so I would say the peak. When is the peak reaches peak in first hour? That's one observation I can make. Look right here. It reaches its peak. Let's say it decreases time at its lowest after 4 hours. So it's at its lowest. Starts to decrease a lot. Decrease even more. 4 to 6 hours. What is it? The tablet seems to stay in the system a little bit longer. Okay. When the two formulations result in the same concentration, when do they result in the same concentration? Well, there's a couple times. You could obviously at 0. Okay. Let's see where else. About right here. About like 3/4 of an hour. And how you want to estimate that, or maybe 2/3 of an hour. Where else? I would say about 6 hours and 6 to 8. Actually, both in between that time, they're about the same. Okay, right in here, they're obviously overlapping here. They come together at 6 and they start to overlap for that. Okay, are there any more questions about this that we need to answer? Oh, sure. So based on the graph, which would you take for pain relief, liquid or tablet? This is your choice. I mean, it's up to you. I mean, if you look at the liquid, I want you to think about this. Liquid's going to get in your system faster, all right, but it's going to dissipate, it's going to decrease a lot quicker. Tablets may take longer for you to feel the results, but it's going to help you over a longer period of time. So this is up to you. Okay. You could say if I want the relief quicker, then I'm going to take the liquid. If I want it over a longer period of time, then I want to take the tablets. Okay, it's up to you. The liquid dose is 500 milligrams per 15 milliliters, or 1,000 milligrams. Okay, that means there is 500 milligrams of acetaminophen. Yep, that word. Okay, for every 15 milliliters of liquid. If 15 milliliters is equivalent to 1 tablespoon, how many tablespoons do we need to ingest 1,000 milligrams of liquid medication? Okay, so they gave us a lot of information. All right, so a dose listed as 500 milligrams is 15 milliliters, and then it says 15 milliliters is equivalent to 1 tablespoon. So 15 milliliters to 1 tablespoon. You see why I type things? To 1 tablespoon, and this gives us the 500 milligrams. But we want 1,000, so I'm just going to multiply all this by 2, which would multiply this by 2. So that means I'll get 30 milliliters, which is 2 tablespoons, which gives me that 1,000 milligrams. So how many milligrams do I need? How many tablespoons do I need to take? I need 2. All right, so again, I'm scaling this by 2 because if 15 milliliters is 500 milligrams, then if I want 1,000, I just multiply that 500 by 2 to get 1,000, which means I have to multiply the 15 by 2 to get 30, which means I will multiply the 1 tablespoon by 2 to get 2 tablespoons. Well, the next page talks about how to make an actual line graph. All right, right here. Okay, I think we've done that before. All right. The last part of this is the connection. So we're going to stop the video here, and we may do this as a class. So come back and check in.